Hello everyone, welcome back to my channel Study with me. Today I'm going to explain about Chemistry Higher Level Paper 1 November 2022. If you find this video is helpful, don't forget to subscribe and please let your friend knows about my channel to support me, and let's get started. How many oxygen atoms are present in 0.05 mole BaOH 8H2O? So to find how many oxygen atom, we will use these Avogadro numbers as well. So N of oxygen would be mole times Avogadro's number and times 10, because we have 8 oxygen here and 2 oxygen here, so times 10. Therefore 0.05 times 6.02 times 10 to the power 23 times 10, and you will get 3.01 times 10 to the power 23. So the answer is C. What is the change of state for a gas to solid? It's deposition. Condensation is from gas to liquid. Freezing from liquid to solid. Sublimation from solid directly to gas. How many moles of carbon dioxide are produced by the complete combustion of 7 grams of ethene? So we need to write the complete combustion of ethene. That would react with oxygen and produce CO2 and H2O. Don't forget to balance the equation. So here will be 2 and then here will be 3. So 7 grams of ethene. So mole of ethene, 7 divided by 28. So it's 0.25 because it's 1 over 4. So this is mole of ethene. So moles of carbon dioxide, so it's double than ethene because coefficient here is 1. Therefore it's 0.5. Successive ionization energies of an element X are shown. So there's first, second, third, and fourth. What energy in kilojoule per mole is required for element X to reach its most stable oxidation state in ionic compounds? Okay, ionization energy is the amount of energy required to remove 1 electron from the valence shells of each atom in 1 mole of gas atom. Okay, so we'll see here there is small difference. Okay, small difference, and then we see here there is large difference, and then we'll see here there is relatively small difference. So we can take the conclusion that the third electron must be removed from a lower shell. So if the third is removed from the lower shell, therefore there are 2 valence electrons that should be easier to be removed, right? So the X compound or X element should have 2 plus oxidation state because there are 2 electrons are easier to remove, but not for the third one. Therefore the energy in kilojoule per mole is required for element X to reach its most stable oxidation state. It's only 2 energy. So 740 plus 1450, which is 2190. Which quantities are different between 2 species represented by notation? This number TE 128.52 and I minus 128.53. Okay, so let's calculate. Proton will be 52 and electron will be 52 as well because it's not ion, and neutron 128 minus 52, it's 76. And for this one, proton it's 53, and then electron will be 53 plus 1 because it's an ion, so 54, and for neutron is 128 minus 53, that would be 75. So they have different number of protons, neutrons, and electrons. Okay? Which best explain why complex of D block elements are colored? The answer is A. All right. So valence D orbital okay, so it should be partially filled. If it's full filled, the transition metal will not display color. So partially filled, it is one of the reasons why transition metal display color. Then okay, valence D subshell in transition metal atom has degenerated orbitals or has the same energy. In transition metal complexes, the nature of the ligand and the specific charge of metal cation involve cause-splitting energy of the valence D electron. Okay, so the valence D subshell in transition metal in a complex, d orbital energies are split. Okay, so electron is promoted. When there is incoming white light, some wavelengths are absorbed. All right, so when the electron is promoted between the d orbital, it will emit light. Okay, the light will be emitted. So the specific wavelength absorbed are associated with the specific energy difference between the d orbital and then specific color. So the light that reflected back through of the salt is missing. This color that is absorbed. All right. So the light that is emitted, it doesn't contain the absorbed wavelength, and so appears a color other than white but complementary color. So it should be absorbed when electrons are promoted between d orbital, not emit. Which elements are considered to be metalloids? Metalloids, they are B, S, I, G, E, A, S, S, B, T, E, N, P, O. So arsenic, yes, and Ge, germanium, yes. So the answer is C. Which property of elements increases down a group but decreases across period? It's atomic radius. Okay, when it goes down a group, atomic radius will increases because the number of electron increases, number of shell increases, and the atomic radius also will increase. But for the electron negativity will decreases because the attraction between the nucleus with the electron and the outermost shell will be weaker, so it will decrease. An ionic radius, because of number of electron will increase, number of shells will increase, and then it becomes ion, so adding more electrons, so ionic radius will also increases. But for the ionization energy, because the atomic radius increases, so therefore it will be easier to remove the electrons. So ionization energy, when it goes down a group, it will decrease. And what about across period? For the atomic radius, because the charge or nuclear charge increases, so the attraction force will increase, therefore it will squeeze, so the atomic radius will decrease. And for the electron negativity, because the atomic radius decreases, so the attraction is stronger, therefore the electron negativity will increase. And for the ionization energy, because the attraction is stronger as the atomic radius decreases, so it will be harder to remove the electron, therefore the ionization energy across period will increase. Which molecule can be represented by resonance structure? It's HNO3, because if we see the structure for H2S, Okay, there is no double bond. H and O3, there's double bond, there will be another Lewis structure. And for H2O2, there is no double bond, there is no pi bond, so it can resonance. The resonance will not happen. And for HClO, also there is no resonance. Which elements are capable of forming expanded octet? Octet rule is the tendency of atoms end up with 8 electrons in their valence shell when they react. Expanded octet when the valence shell contains more than 8 electrons. So nitrogen with the proton number 7 and electron number 7 has electron configuration 1s2, 2s2, 2p3. And for the phosphorus is 3s2, 3p3. And for arsenic is Ar, 4s2, 4p3. Okay, arsenic electron number is 33, phosphorus is 15. All right, so why the answer is 2 and 3? So for phosphorus, it has unpaired electron, so there is vacant 3 more, and for arsenic as well, and for nitrogen as well. But for phosphorus and arsenic, it has the possibility to reach to 3d0, and also arsenic it reached to 4d0, so it has more vacant electron, so I mean orbitals. So for nitrogen, it cannot reach to d orbital because it's only until 2. So the possibility only for phosphorus and arsenic, it has more empty d orbital and unpaired electron in p and as, so more atoms can be bonded to phosphorus and arsenic, as they can more accept electron compared to nitrogen. Which molecule has a tetrahedral molecular geometry? So let's draw the structure. NO, H, O, and O. And for SF4, all right, and for XE, O4, and for XEF4. Okay, so it has 6 domain and 2 lone pairs. So the molecular geometry for XEF4 is square planar, and this one 4 domain, it's tetrahedral, and this one is 5 domain, 1 lone pair is seesaw, and this one is trigonal planar, okay, for N. And therefore the answer is XeO4. Alloying a metal with a metal of smaller atomic radius can disrupt the lattice and make it more difficult for atoms to slide over each other. Which property will increase as a result? Okay, so if we draw the structure of metal, it will be very rigid or regular arrangement. And then for alloy, it has different size of atom, so that would be maybe like this, and yeah, okay. So for metal, cations are arranged in a regular arrangement in a C delocalized electron, so they can slide over one another without disrupting the bond, so they are malleable, can be hammered into a shape and drawn into wire, which is ductile, and conduct electricity due to delocalized electron, okay, for metal. But for alloy, layers cannot slide over one another, as the lattice will be disrupted, and less ductile and also less malleable, therefore is a lot stronger compared to metal. Therefore the answer is strength. Chlorofluorocarbon CFCs contains bond of the following length, CC, CF, and CCl. As we can see, CCl is the longest one, and CF is the shortest one. So if we make it into order, it would be CCl, CC, and then CF, short, and of course it will be a lot stronger. Okay, so the answer will be C. So increasing, CF is more strong compared to CCl and CC. What is the value for enthalpy of formation of methane from the given enthalpies of combustion? So for the enthalpy of combustion of this, and we need to know the enthalpy of formation of CH4, which is CS plus 2H2 produce CH4. Okay, so it should be at their standard state from C and then H. So as we can see, C is on the left side, so it's good, should stay the same, coefficients also the same. And for H2 is on the left side, but should be double, therefore is times 2. And for CH4 is on the right side, but here is on the left side, so we need to reverse. Okay, let's write back down the equation. CO2 gas, 2H2 gas, and oxygen gas, so become 2H2O liquid, and this one 2H2O liquid plus CO2 gas because the reverse, CH4 gas plus 2O2 gas. This will be finished because 2 and CO2 also and H2O also, so we've got what we are looking for. Okay, so it stayed the same, so negative 394, and then times 2, so between this and this, and reverse should be plus, so therefore the answer is D. Which magnitudes of lattice enthalpy and hydrogen enthalpy of ions for an ionic substance would result in the most exothermic enthalpy of solution? Okay, magnitude is the amount of energy is released or absorbed. So lattice enthalpy, it's positive, always endothermic, and hydrogen enthalpy always exothermic. Okay, so if it's always exothermic, so this should be very large to keep it to be exothermic, and this should be small to try to reduce the positive sign of the lattice enthalpy. Therefore, it should be small and large, so it's C. Which alkane has the lowest standard entropy? The key here, lowest standard entropy should be the simplest molecule. It's A. So as it is simplest molecule with the fewest atom, so it has lowest standard entropy. The opposite, C4H10, has highest entropy because it is more complex molecule with the most number of atoms. At which temperature could delta H, delta S, and delta G all be positive? So delta G is delta H minus T delta S. If at low temperature, okay, if both delta H and delta S are positive, T delta S will be smaller than delta H. So the process will be non-spontaneous. Therefore, delta G will be positive. If both delta H and delta S positive at high temperature, so T delta S is bigger than delta H. Therefore, delta G will be negative and is spontaneous. Okay, so at low temperature. What initial rate of reaction can be determined from the graph? Okay, if you do all of this, okay, and we draw the line, okay, and we do the tangent, this will be 0.2, and this will be right here is 2. Okay, so initial rate will be 0.2 divided by 2, which is 0.1. Which changes would increase the rate of an exothermic reaction? It's temperature increase and particle size decrease. So exothermic reaction increase in temperature. And for the particle size, smaller particle size increase the rate of reaction because the surface area of reactant increases. All right. Data is given for the reaction 2x2 plus y2 produce 2x2y. What rate equation can be inferred from the data? So we'll see these two are the same. Therefore, we can find this order of reaction of x2, order of x2. So double the concentration, quadruple. Therefore, for x2, second order. And for y, okay, y2, these are the same. And we check the concentration, double the concentration, but the rate stay the same. Therefore, for y2, 0 order. If it's double the concentration, double the rate, it's first order. Double the concentration, quadruple the rate is second order. And if the double concentration, the rate doesn't change, stay the same, it's 0 order. Therefore, the answer is C. The activation energy of reaction can be obtained from the rate constant K and the absolute temperature T, which graph of these quantities produce a straight line. So the equation of Arrhenius is K A E to the power activation energy divided by RT. So ln K will be ln A minus EA divided by RT, or ln K EA divided by R times 1 over T plus ln A. So you can see here ln K and 1 over T. So the graph will be like this, 1 over T and ln K. So this is the slope, okay, y mx plus b. Therefore, the answer is D. For the reaction I2 plus 3Cl2 produce 2ICl3 at a certain temperature, the equilibrium concentration are in mole per decimeter cube. So I2 plus 3Cl2, 2ICl3, so 0.2, 0.2, and 2. So the equation is Kc ICl3 to the power 2 divided by concentration of I2 and Cl2 to the power 3. Okay, let's plot into the formula. That would be 2 to the power 2 and 0.2 times 0.2 to the power 3. That would be 4 divided by 16 times 10 to the power negative 4 is 2,500. Okay. Which of these changes would shift the equilibrium to the right? Addition of 0.01 molar HCl is very dilute solution. So adding this will not give any effect for the additional of Cl minus ion. An addition of concentrated of HCl, it will add Cl minus ion, so it will make the equilibrium shift to the right. Evaporation of water will reduce the amount of water, and we have a water on the product. If the concentration of product decreases, it will shift to the right even though it is in liquid form, but once liquid is evaporated, it will reduce the whole volume of solution and increase the concentration. Okay, so the answer will be 2 and 3. Equal volumes of 0.1 mole decimeter cube weak acid and strong acid are titrated with 0.1 molar NaOH solution. Which of these is the same for the two acids? For the initial pH, weak acid will have higher pH compared to the strong acid. And for the heat evolved in the neutralization, strong acid will evolve more. And for the initial electrical conductivity, strong acid will have higher initial electrical conductivity because it fully dissociates. And for volume of NaOH, for complete neutralization, while the concentration is the same for one that is weak and another one that is strong, but if the number of mole is the same, it will require the same amount of base to neutralize completely, right? So the answer will be C. Which species has the weakest conjugate base? So for HCl, just imagine strong acid in the water will produce H3O plus and A minus. So H2O as an acid gives HA as an acid donates proton to H2O. So this one will be conjugate base. So the sign here is not equilibrium because the conjugate base cannot bond back to H plus because the strong acid will dissociate completely. In case of weak acid, okay, it will be partially dissociate, so therefore their conjugate base able to bond back with H plus. Alright, so the key here, the strong acid will produce weak conjugate base. The weak acid will produce strong conjugate base. Therefore, the answer is A. For NH4 plus, this one is conjugate acid. Okay, the reaction is NH3 plus H2O will produce NH4 plus and OH minus. So this will act as a conjugate acid. And for this one, CO3 2 minus plus HSO4, okay, will produce HCO3 minus plus SO4 2 minus. Yes, this is conjugate base, but it is from weak acid. Therefore, it will produce strong conjugate base. And for water, is an amphoteric that can react with base and acid. Alright. Which solution will form a buffer when mixed? The first one, it has the same amount of mole because same concentration and same volume, and a strong acid and strong base, so it's a neutralization. And for B1, it is weak acid and strong base, the same concentration and the same amount of volume, so weak acid will be finished with the strong base. So it is not suitable for the requirement making buffer solution where the weak acid should be in excess. And this one, NaOH is in excess, so this is not suitable for for making buffer. And for this one, weak acid is in excess, so the answer is D. Which species can act both as a Lewis and a Lewis acid and a Lewis base? Is H2O, because H2O is has amphoteric character, where it can be Lewis acid and Lewis base. For example, as a Lewis acid, H2O react with NH3 will produce NH4 plus and OH minus. So H2O will accept a pair of electrons from N and is acting as a Lewis acid. And for Lewis base, H2O react with HCl, produce H3O plus and Cl minus. It gives a pair of electron, donates a pair of electron, acting as a Lewis base. Okay. What occurs during the operation of a full-take cell based on the given reaction? So Cr, this plus 3, 0, plus 2, 0. So Cr experience oxidation, and Fe reduce the oxidation number, so it's reduction. In voltaic cell, electron movement from the anode, which is negative electrode, and to cathode, which is positive electrode. Okay, anode always oxidation. Okay, oxidation, so this should be Cr, and cathode reduction should be Fe. And the electron movement is from anode to cathode, so from Cr to Fe, from Cr to Fe, so between A and B. And ion movement in solution, in the reaction it produces FeS, right? So therefore Fe2 plus move towards FeS, not move away. The answer is B. What is the coefficient for H plus when the equation below is balanced? You need to make the half equation. We have Pb, S and Pb, 2 plus aqueous. So this here will be 2 electron, okay? Then the charge are balanced. Now we have NO3 minus and NO, gas. Number of atom of N are equal, but not for oxygen. So oxygen here is 3, oxygen here is 1. To make it balance, we need to add H2O. We need 2 H2O because 2 more O. Then now H are not balanced, so we add H plus on another side, which is 4 because 4H plus. Now we see the charge. Here is negative 1. Here is plus 4. So the charge is plus 3. There is no charge here, 0. So it means we need to make it 0 here by adding 3 electron. Negative 3 plus 3 becomes 0. So now it's balanced. But for the first one is 2 electron. For the second one is 3 electron. Then we need to multiple 3 and multiple 2. So now 6 electron, 6 electron. You can add them both. So that would be 3 Pb and NO3 will be 2. H plus will be 8. Pb2 plus will be 2. NO will be 2. H2O will be 4. So the answer is D. The standard electrode potential for 3 half cells involving chromium are shown. Which statement is correct? Okay, the higher reduction potential, the greater tendency to be reduced. It will oxidize lower potential. So the higher, okay, if we compare 0.744 is higher compared to negative 0.914. Therefore, Cr3 plus will be able to oxidize Cr. But it cannot oxidize Cr2 plus because between this number and this number, it's lower. So the answer is B. It can oxidize Cr, but cannot oxidize Cr2 plus because it has lower potential number. Which factors affect the amount in mole of product formed during electrolysis? Alright, the greater the time the electrolysis, the more products will be formed. So this will give an effect. And the charge also affects. Higher charge that goes under reduction process will possess large negative reduction potential value. Thus, it will get deposited more at the cathode as product. This one. The molar mass of the ion will not give any effect. Okay? So, the answer will be B. Okay, which are isomers of C5H12? Let's draw this one so it will make it more clear for you to see the number of C and H. So this will be CH3, this will be C, this will be CH3, this will be CH2, we have one H right here, and then this will be CH3. And for this one, CH3. This will be C, this will be CH3, and this will be CH3, and this will be CH3. For this one, 1, 2, 3, 4, 5, 6, C. Obviously, no. And then let's check. C5H12. The same goes C5H12. So 1 and 2 only. Which compound has a chiral carbon? Bromomethane. CHBr and HCH3. Bromomethane. Ethane. And for B is CH3, CHBr, CH3. It's 2-bromopropane. And the third one, or C, CH3, CHBr, C2H5. So 1, 2, 3, 4. Butane, 2-bromo. And the D, C2H5, CBr, HC2H5. The same. Sorry, not this the same, but for this one, different. So chiral carbon is bonded to the fourth different molecule. So the answer will be C. Which condition best favor oxidation of primary alcohols directly to carboxylic acid? It's B. It's reflux, okay? Acidify potassium dichromate excess, but not distillation, but reflux. Which statement best describes retrosynthesis? Retrosynthesis, it means deconstructing a target molecule into readily available starting material by breaking of bonds by the conversion of one functional group into another functional group. So basically, designing synthetic route involving backward from the target molecule to identify starting materials and intermediate steps needed to synthesize the target compound. Therefore, the answer is B. What combination of reactants will convert nitrobenzene to phenylamine in two-step? You need SN and concentrated HCl. Actually, we need heat as well, and NaOH. So there is OH here, OH and SN. A well-tested scientific idea which has been used to make predictions cannot explain a particular event. Which statement describes the scientific approach to this dilemma? When a well-tested theory fails to explain a particular event, the preferred course is to revise the theory rather than discard entirely. This allows for the incorporation of new evidence or alternative explanation while still maintaining the core. So we cannot discard, it's D, so we cannot discard it entirely, directly say it's wrong, but we need to check and revise the theory. What information about 2-hydroxybutanoic acid can be inferred through mass spectrometry? Okay, so the compound 2-hydroxybutanoic acid. Butanoic acid, okay, so COOH, and you have CH2, CH3, so this butanoic acid, 2-hydroxy, okay, so we start from 1 and then 2, so you give OH. All right, so the molar mass here is 104. All right, so we have MS, IR, and NMR. MS, it used to determine molecular weight. So the molecular weight can be determined, which is 104. So this is correct. And then IR, to identify functional group. So it should have carboxyl and hydroxyl. So it's IR. And NMR, analyze the structure Where is OH? OH is on the second C, not the fourth carbon. So the answer is A. What information can be deduced about a compound through X-ray crystallography? X-ray crystallography can predict bond angle through the crystal structure to predict the distance between atoms. So they can predict the bond angle. Which organic compound has the NMR shown? So it has 3 phenol. Let's say we draw methanol. Okay, it has 2 phenol only. And for the ethanoic acid, again, OH. Okay, again, 2 H environment, 2 phenol. And then for the third one, it's methyl ethanoate. So that would be again 2 phenol. Okay, so for the third one, propanoic acid, there is 1, there is 2, there is 3. So 3 phenol. Therefore, the answer is propanoic acid. Alright, so that's all for the explanation. Paper 1, November 2022, higher level. If you guys find this video is helpful, please don't forget to subscribe and let your other friend knows about my channel to support me. And that's all for today. Thank you for watching. Bye.